Hello students, welcome to our lecture series of Introduction to Food Chemistry. Today we are going to lecture 8, and in this class we would like to understand more about lipids. We are going to cover the basic concepts of lipids, and we shall understand the food chemistry of lipids. Lipids are composed of carbon, hydrogen and oxygen atoms, as it is with carbohydrates that we looked at previously. Their hydrophobic nature arises from long hydrocarbon chains or rings that make them insoluble in water. They are organic solvents that are soluble but insoluble in water. They can be found in adipose tissue in cell membranes. The lipids are composed of fatty acids and glycerol, which gives us a triglyceride, which is the primary lipid. Lipids can be divided into two, the fats and oils. The fats are solid at room temperature and the oils are liquid at room temperature. The functional roles of lipids include energy production, essential fatty acid production in the body. They can also work as vitamin carriers, and they also add flavor to our food. Polarity of lipids. Lipids can be categorized based on their polarity. And under this, we have the nonpolar lipids and we have the polar lipids. The nonpolar lipids lack the polar functional groups, and this makes them hydrophobic. And under this, we have the triglycerides that are composed of glycerol esterified with 3 fatty acids, and they are primarily involved in energy storage. We also have cholesterol, which is a sterol with a nonpolar hydrocarbon structure, and it mainly contributes to the membrane fluidity, the cell membrane. The polar lipids, they can also be called amphipathic or amphiphilic lipids. These lipids contain both the hydrophilic or the polar group and the hydrophobic or nonpolar group. Under this, we have the phospholipids, which consist of a glycerol backbone, 2 fatty acids, tails, which are hydrophobic, and a phosphate-containing head group, which is hydrophilic. This amphipathic nature enables them to form lipid bilayers in the cell membranes. We also have the glycolipids, which are similar to phospholipids, but they have carbohydrate groups and they play key roles in cell recognition in the body. Dietary lipids. We have various types of dietary lipids, and among them we have the visible fats that include butter and lard, and then we have the invisible or constituent fats. Under this we have milk, cheese, and meat. And these dietary lipids can be affected by processing or storage, and there are key reactions that are important when it comes to dietary lipids, that is oxidation and rancidity, which we shall look at later on. The edible fats can be classified into various groups. One, we have the milk fats. Under this, we have the palmitic acid, the stearic acid, oleic acid, plus short chain fatty acids, including chain 4 up to chain 12, short and the medium chain fatty acids. Then we also have the lauric acid group, including the coconut oil, and then also high carbon 12 fatty acids, and also they have low unsaturation. The vegetable butters include the tropical seeds that have narrow melting range. We have the oleic, linoleic group, and these ones are commonly found in vegetable oils such as soy, corn, and sunflower. We have the linolenic group, including the soybean, flax, and they are high in omega-3 fatty acids. The animal fats are rich in the carbon 16 to carbon 18, and they have moderate unsaturation levels. We also have the marine oils. They have high omega-3 fatty acids, the polyunsaturated fatty acids, They also have the vitamins A and D, and they are also prone to oxidation. Fatty acids, we have the saturated. They can also be classified according to saturation, under which we have the saturated and the unsaturated fatty acids. Saturated fatty acids have no double bonds, but the unsaturated have one or more double bonds. And this kind of property or nature affects the physical properties of fats and their behavior upon cooking. We have what we call the acyl glycerols. These are esters of glycerol and fatty acids. The types here, we have the monoacyl glycerol, diacyl glycerol, and the triacyl glycerol. Example of this, we have the tristearine, which is the carbon 18 fatty acid with a glycerol backbone. Phospholipids. We said phospholipids contain a phosphate group, and we also have the glycerophospholipids that contain a glycerol group plus the phospholipid group. This one has glycerol, 2 fatty acids, and a phosphate. These ones have both the polar head and the 2 hydrocarbon tails, and they are very important in the cell membrane structure. Properties of lipids, we have lipids are insoluble in water, but they are soluble in organic solvents. Fatty acids can be saturated or unsaturated. We said the saturated has no double bonds, and the unsaturated contains one or more double bonds. The natural sources can vary in lipid content. For example, oil, 99%, and milk, 4 to 6%. What is the nutritional role of lipids? Lipids provide essential fatty acids, as I said earlier on, and they are also important for the movement and storage and utilization of the fat-soluble vitamins, that is vitamin A, D, E, and K. And the health impact here is that if you consume unsaturated fats, they are healthy for the body because they lower the risk of subchronic heart diseases. And we also have to note that these lipids, especially the trans-saturated fatty acids, they are not healthy for the body because they contain the bad cholesterol, which causes clogging of the blood vessels and cause poor movement of blood in the body. For more details, you can go and read more about the trans-saturated fatty acids. There is more you need to understand about them, including their health implications and how they are produced and why they are not healthy for the body. The functional roles of fats and oils. Fats and oils contribute to the texture of foods, palatability, aroma, and mouthfeel. Analytical properties of lipids. One of them is the melting point, which ranges due to mixed triglycerides. Saponification number. This one indicates the fatty acid content. The iodine value measures the level of unsaturation and fatty acid chain length. Here we can have the short chain fatty acids, the medium chain fatty acids, and the long chain fatty acids. Rancidity refers to the spoilage of fatty acids or lipids due to oxidation, microbes, and also hydrolysis. Processing of lipids. We have various processes that are used when you want to process lipids, and one of them is hydrogenation. This one reduces the level of unsaturation, and one of the major products here is margarine. It's produced by hydrogenation. We also have interesterification, which enhances spreadability. It makes it smooth and easy to spread. For example, butter. Then also crystallization. Some of these lipids can crystallize, and this affects their texture upon cooling. Triglycerides. What is the structure of triglycerides? Triglycerides, we have noted that they are composed of 1 glycerol and 3 fatty acids, and it's also formed via esterification. Glycerol is equal to propan 1,2,3 triol, and the fatty acids are also contain the long chain carboxylic acids. The properties of triglycerides is that they can also be fats, which is solid at room temperature, and they can also exist as oils, that is liquid at room temperature. And these properties also depend on the chain length and the degree of unsaturation or the number of double bonds present. Other lipids in foods, we have noted that we can also find other lipids in foods, for example, the phospholipids like triglycerides, but one fatty acid is replaced with a phosphate group. The sterols, for example, cholesterol, have the tetracyclic ring structure. Cholesterol is good for the body, but it has to be balanced. The fat content in common foods, for example, butter or margarine contains about 80 to 100% fat. Milk, approximately 1%. Ice cream, 10%. Cheese, 30%. Cream, 40%. Eggs, 30%. Chocolate, 30%. Nuts, 70%. And then cakes or pastry, 15 to 40%. White meat has 25% and red meat 40%. And what is the significance of these percentages? These percentages can help you choose the kind of foods you want to consume. If you're aiming at consuming high fat foods, then you're going to look at the percentage, then you consume. If you're aiming at low fat foods, then you have to also look at the percentage and choose among them which ones have a low fat content. The fatty acids, what are some of the variations in fatty acids? Triglycerides often have different fatty acids. For example, in chocolate, palmitic acid has 16 carbon chain and 0 double bonds. And then stearic acid also has 18 carbon chains and 0 level of double bonds. Then oleic acid has 18 carbon chains and 1 double bond and occurs in the cis configuration. In the fatty acid configuration, we note that there are 2 forms of configurations, the cis and the trans. The fatty acids, the chain length categories can also vary. Like I said earlier, we have the short chain that is less than 6 carbons, the medium chain 6 to 12 carbons, long chain from 13 to 21 carbon, and we also have the extreme with very long chains over 22 carbons. And the longer chain is equal to a higher melting point. The shorter the chain, the lower the melting point, and the higher the chain, the higher the melting point. Fatty acid saturation, we already talked about this. Non-saturated have double bonds. The saturated has no double bond. And this is basically what we have for our lecture 8, Introduction to Lipids. And next to this, we are going to look at the nomenclature of fatty acids and also triglyceride chemistry. Thank you.